introduce you to 3DHero, an interactive puzzle game platform for 3D spatial and reasoning training using a game engine and machine learning. Allow me to introduce you to the game. The original 2D version of this puzzle game Tetris was made by the Soviet-American game developer Alexei Pajitnov in 1984. And ever since it became popular, variations have been released. Research from Mind Research Lab in Albuquerque on the original game has led to research on variations of the game and its effects on autism. 3D variations of Tetris are relatively obscure compared to 2D variations, including 2D variations with 3D graphics, so I decided to make a new one. And in making a new one, I sought to make mine different. Difference between this version and already existing ones. Blockouts P6 consists of polycubes and monocubes as well. 3D Tetris is the same, but there are also polykings and some arrangements where cubes aren't even connected at all. Both have next cube. 3D Tetris has an isometric camera and a cross-section view, whereas Blockout only has a top-down view. For my game, this piece set solely consists of the 8 one-sided tetracubes. Note that S and Z are counted as one tetracube because they are not chiral in 3D. Same applies to J and O. There is no next nor hold cubes in this game. This game contains an orbital isometric camera which allows the player to view the entire field. Sadly, dragging the orbital camera does not stop time. Remember to pause the game so that you have an advantage. There are also sided field cameras akin to the original 2D Tetris. This game was coded using Unity and C++, but reading the code itself would take an extremely long time. However, if you show any interest in the source code, you can consult the paper. On to the building blocks of the game. Part 1. The one-sided tetrominoes. As I mentioned before, these two are chiral pairs in 2D, but they are the same in 3D. So are these two. TIOZSLJ. But adding on to these ones, you have the ones on here, which cannot exist on one plane, and thus have to take up 2 rows of 2 planes of cubes. Purple and turquoise are a chiral pair, and magenta is a tripod. And this is a flowchart for the randomizer and spawner. So you start the game, and the game generates a random tetracube from the list of tetracubes. Then it spawns the tetracube on top of the playing field. And it generates the ghost piece as well. You drop the piece and then wait, and it waits 0.5 seconds after the piece reaches its final position. It locks the tetracubes, it checks if it blocks out. If not, it repeats the cycle, but yet, if it does, then it's game over. This is the graph of the shader I used for the tetracubes. It is a little complex though. Shown is a shader in action with an S tetracube, aka N or Z. And in black is the ghost piece. The gray is just shadows from the light sources in Unity, native that is. A video playthrough of this game. In case you were wondering, the pieces do not rotate like they do in actual Tetris. They rotate on a central cube rotation system. That means O spins are technically possible within the game. This is footage of me playing the latest build of this game. As you can see, this is the camera dragging functionality. And the only difference between S, Z, J, and L are the colors and the direction they spawn in. Sadly, there is no music because I didn't put any in there. But I'm hoping to add Korobaniki in. In case you don't know what Korobaniki is the music associated with Tetris. Controls. Arrow keys to move, WASD and Q to need to rotate, space to hard drop, J to soft drop, click and drag to rotate camera, tab to switch camera views, which I didn't showcase, and escape to pause. And then we proceeded to do an experiment. This time we got 9 kids of different ages to play this game, and we tracked their focus times. As you can see, ages 7 through 10 had like 15 seconds of focus times. Around 17-ish for 11 to 13, and around 10 for 13 to 15. And that was for the first day. The next day, they improved. Ages 7 through 10 reached around 16.25. 11 to 13 was around 19, and 13 to 15 reached around 12. And the next day, 7 to 10 reached 30 seconds, 11 through 13 reached 22.5 seconds, and 30 to 15 reached 23 seconds. Results. Essentially, by playing this game, it would lead to an increase in focus time in autistic kids in ages 7 through 15, especially in those ages 7 through 10, from 50.1 seconds to over 30 seconds. Conclusion. This 3D version of Tetris can help children on the autism spectrum when it comes to spatial and reasoning training. For more information, please check 3dtetrisgame.com. Thank you very much.